While that's starting in the background, I'll just close down this timer. So there's a few people that look like they've just joined. So I'm just going to copy the link address and I'll put that into the Zoom window. So before the break, we started our virtual lab and we started our mini network simulation, and we started to look at the controller and the flows that were put into our OpenV switch. So from there, I'm just going to go back because I didn't show you the actual communication between the controller and the device using that secure channel. And so that's what we're doing here on the right-hand side. If I go and create a snoop, so dpctl snoop, and the ampersand means run it in the background, I press enter. So that's going to continually listen in on that traffic. And now if I do my dump flows, what we will see is that request, the hello request, the reply. So this is the keep alive that's happening. So we're not doing a complete feature set at this point. That means that we can now do a H1 in H2. I'm going to just set it to 1. So we get 1 received. And if I do that flow again, we should see that secure channel communication. So there's our metadata that OFP packet in. And this is why I got you to do it through the actual GUI interface rather than doing it directly on the device in this command line, because you wouldn't be able to scroll back. And so what we've got here is the type of traffic that is communicating on that secure channel between our OpenFlow device and the controller, the OpenFlow controller. So this is our keep alive information. So making sure that it's got connectivity with the controller. But as soon as a packet comes in, which we've got this here, the OpenFlow protocol packet in, it's going to say it came in on this port. It looks up its table, in this case, the table 0, and it realizes there is no match. So what do I do with that? So I'm going to send it out, and that's what this is doing here. Pack it out, and the action is to flood it through all ports. And it will get a response from that port 2, which is what router 2 is on. So based on that, it's going to try and figure out, just like our normal ARP resolution, the address resolution protocol, how it's going to do certain things. I can't scroll because I start annotating. So if I can click the drawings. And then what it's got here is it's got the no match for our port 1. It then sends it out and it receives that information and goes, hold on, I've received this no match. What should I do? And it actually does this OpenFlow mod. It's going to add, and it's saying ICMP coming in on port 1 with this information, the MAC address of this, destination address of this, IP of this, ICMP packet type 8. What should I do? The action is output to 2. And then it's going to get a packet coming in. And based on that, that's the response from our port 2. It goes to the controller and goes, what should I do with it? The controller sends down this flow modification, and it's going to add that flow entry to our table 0. And then it's going to allow that to continue. Okay, so that's the secure channel communication that we've enabled on our network simulation. So this is all inside this one simulation. So it's probably not going to be useful in a production network because you want to be able to communicate to the real devices, the hardware devices, or be able to have your own controller set up. So that's what we're going to start working with next. So what we're going to do is set up what's called our open daylight controller. Now, since the start of our course that we created, there has been some changes to the standard. So the open daylight controller, the actual web interface, what we're going to be using today, it is no longer an active project. So you can still set it up and configure it if you would like to, but there are other more suitable web interfaces that are more vendor specific. So you won't necessarily do this in the production environment today, but you can at least test the functionality of it using the software. So I'm just going to open up another terminal window. I do an LS. I've already pre-installed the Open Daylight controller here. So we've got Carafe, and we've also got the Open Daylight OpenFlow app that Cisco uses. So Carafe is a web or Java framework that runs on Apache that allows us to run our web interface. So I'm just going to change into that directory. And from that directory, I have the Carafe program. Now, in production, you shouldn't be running your web interface under root. The way that this is built in a hurry, we didn't break it out into its own user group and set the permissions correctly. But you can start running it, and the password is under resources, and it's APNIC, or you go to instructions. Go up to the type text, type password. What this is going to do is it's going to run the back end for you. Now, if you went and downloaded the Git repo and set this up today, it's taken a lot of the WebGUI plugins out of the repo. So if you're a programmer, you're welcome to create your own plugins, or you can build on to that. For our lab that we're doing today, we use the Deluxe plugin, the Open Daylight Deluxe Core apps, to be able to access a web interface that shows us the AIM model, our topology view, and being able to just see some of the interactions between our Open Daylight controller and our Open vSwitch. There are some other tools that we need. So the layer 2 switch capabilities as a plugin, and our RESTconf to be able to interact with our device and configure it. So to look at our plugins, we're going to look at our feature list. And we can see from this feature list, I might just make my screen a little bit bigger, so that way you can see it laid out a little bit nicer. But we've got to I'll clear the screen and just run it again. It's taking you up to the top. There's about 200 and something different plugins that we've got here by default, but there's a whole heap of approximately about 4,000 other plugins that you can access all once. So I'm just trying to get to the top. Here we go. So what we've got across the top, we've got our name or the caption that is used for that, our version, our required, whether it's required, whether it's installed or not, where it's getting the plugin from, and the description for that plugin from that. So anything to do with Open Daylight, or if we just want to have a look at the installed, we can go and add the -- installed, and it now just lists all the installed and what state they're in, whether they're started or not. Now, these are the software that you need to enable for your Open Daylight controller if you're going to install it yourself. By default, in this lab environment, I've enabled these already for you. What we can also do is we can see if there's any required software for certain tools that you may be enabling. And this is what we've got as required. So we've got here the layer 2 switch, our deluxe apps, our API documents, our deluxe web interface, our RESTconf, and some other tools there. So now that that is running, we can go to our browser. In this case, it's going to be Firefox, if I can see my cursor. And it will, I've set the home page as the controller. So if you've got it running correctly, you should see this login page, and the password is the default settings of admin. So when I log in, it will take me to the Yang visualizer. We don't actually have our simulated network running at this point, so there's not much we'll see until we start our network or connect our Open vSwitch to our controller. So I'm just going to go to the next section. So now that I've got this running, I'm going to get you to create a packet capture so you can drill down on the actual communication between the network simulation, which has got the Open vSwitch, and your Open Daylight controller to look at that packet capture, looking at the packets that are sent between the two devices. So I'll get you to open up another terminal window, or you can open up Wireshark from the GUI and manually set up your configuration. I just find that this works a little bit better. So I'm saying Wireshark to start it using our interface, in this case ENS32, that's the one that communicates to our Mininet server. And then I'm telling it to only look for the OpenFlow traffic, in particular the 1.3 version. So that's what V4 is referring to. And filter that, and hopefully that's going to start that. Wireshark, have it running, and it's got that display filter happening there. Going to the Mininet interface. I'm going to drop back out from there, and I'm going to specify the connection to my Open Daylight controller using the controller equals remote IP and so on. And I'll just copy that. That way you can see it a little bit better. There we go. I'll just annotate that so you can see what we're doing here. So what we've got here, oh, it's probably too small. That should be big enough for everyone to see. So I'm just going to annotate that. So we're familiar with this command here. That's starting our network simulation, and we're using a simple MAC address. We also used the controller in a previous example, but we said none. This time we're saying we want a remote controller, and we need to specify the IP address and the port number. This is important because this one here is referring to a newer version of our OpenFlow protocol, and the older version is looking at, if we remember when we ran just this command, it showed that our listening port for the controller was 6653. So that means that's older protocol for OpenFlow. We then specify the type of switch that we're using, ABS, and by default, the MiniNet simulator is using OpenFlow 1.0. We want to use a newer version of OpenFlow to run it with the Open Daylight controller. So that's why we're adding this command here. So we're going to specify looking at the OpenFlow protocol 1.3, which is that on the wire command of the 0x04. So that's what this is saying here. Start my network simulation with the two hosts and Open vSwitch that supports OpenFlow 1.3, and it's going to connect to this IP address on this port number. I type in net, I should see that I've got my details there. If I type in dump, we can see that it's actually got the communication happening on that 6633, and it's communicating. And in the background, you can see I've got this updates happening in my Wireshark configuration. So if I try to see what's happening in my dump flow, so if I just do that, I'm not going to see anything because it's going to say, hold on, there's a problem. The reason is that it's trying to connect to an OpenFlow switch using OpenFlow version 1, but the switch is version 1.3. One thing to be aware of is that it is not backward compatible. So if I'm running a hardware device that only supports OpenFlow version 1.3, it will not communicate with something that is trying to communicate using OpenFlow version 1. So it doesn't have that backward compatibility. So what I need to do is to specify what protocol to communicate with. So protocols equal OpenFlow 1.3 without the full stop, and now I will see the communication. So we can see here I'm getting just some simple communication with the controller on the details there. Okay, so that's a priority. That's secure communication. If we go to the web interface and go to the topology, which I can never see from here. There we go, topology. All I've got is just my OpenFlow vSwitch. I can't see my hosts. The reason for that is that there's been no communication, so the controller hasn't had a need to map that topology at this point. All it needs to know about is that it's got a secure communication with the OpenFlow switch. So if I go back to my terminal window and do a ping, I've got the communication happening there. I go back to my web interface, do a reload, and it now will show me that communication between the two hosts. If we then go and have a look at our Wireshark setting, there it is here. I'm just going to stop that because I don't need it anymore. And what I can do is I can modify my display. So currently I'm only looking at OpenFlow v4 traffic, but if I look at a particular type of traffic, and I'll explain this when we go back to the tiering. Oh, added an extra character in between the equal sign. Better. And so I see this type version 14 or type number 14 is where it's doing that OpenFlow modification. And I talked about that before the break. So if we open that up and drill down, we can see that we've got this match field. Get into there. Oh, this is, I'll need to explain it a bit later on. So this is how it does this discovery. It uses a linked layer discovery protocol to allow it to tell the switch to send out these protocols and discover what's connected to where to get the network topology. But essentially what we've got here is that it's going to look for the LLDP protocol, and what the action is, it's going to send it to the controller. Let's go to later version of that protocol. And this is the one I was after, so I'll drill down on that. So what we've got here is this is the one for our ping. So it's saying the field is going to be this destination Ethernet address going to this from this source address. What should I do with that? And the action that's associated with that. So that's the ping from the host 1 to the host 2. If we then look at our type 13, that's going to be that packet out setting. And so from the packet out setting, it gives you details about where to send that particular packet. In this case here, it's going to the controller and so on. We have a look at the type 10, that's the packet in. So when a packet comes in, what I'm going to do with it. So you've got your flow mod, packet out, packet in. So flow mod is type 14, packet out is type 13, packet in is type 10. Any questions about that? So what we've got is we've got our hardware device, in this case it's a network simulation, connecting to our Open Daylight controller using the southbound interface. That southbound interface is able to retrieve information from the device about connected hosts. And when a packet comes into the device, that Open V switch, it sends that to the controller. The controller makes a decision about that and sends it back to the Open vSwitch on what to do, the particular action. If we want to modify those actions, we can use a command line interface to do that, or we can use some sort of application. And that's what we're going to do now, is set up the Cisco OpenFlow manager to be able to set up a rule to drop traffic. So we're going to create a simulated network where we've got 3 machines, host 1, 2, and 3. We're going to allow host 1 to ping host 3, but host 1 cannot ping host 2 or be able to communicate. Now, we don't need to leave the Wireshark open, so I'm going to close that down. You're quite welcome to play around with that a little bit more. Just going to go back to my MiniNet and shut that down. So I'm going to run that same command as before. Only difference now is that I'm going to change my topology. See how I've got this dash topo, TOPO, and I'm saying single, so single switch with 3 hosts. So I can do quite a complex setup if I want. We can see here that when it created, it's now created host 1, host 2, host 3. I do my net and my dump. I can see the IP addresses of those 3 devices. And I can see I've got communication with my Open Daylight controller. So my Open Daylight controller is going to be communicating with the device. My Cisco OpenFlow manager is going to be communicating with my Open Daylight controller. And then that tells the Open Daylight controller to communicate with the Open vSwitch. If I do a reload of this topology, I've lost my hosts at this point. And if I go back to my there, if I go back to my MiniNet and type in ping all, this is a way to do a quick ping of all the devices and then draw out my topology. So if I do a OpenFlow reload, I now see I've got 1, 2, and 3 hosts there. Very simple. So from there, I'm going to go back to my terminal window. I'm just going to click on that. Shut down my Wireshark terminal window. I'm going to open that. Helps if I spell clear right. Clear the screen, and I'm going to change into my Open Daylight OpenFlow application, which is that Cisco OpenFlow manager. And inside here, it's using the Grunt framework to run the application. So I'll just type in Grunt, and it's basically set up a web interface to communicate on port 9000. So I go to my web browser and click on the Open Daylight and show the devices. I should now see I've got connectivity there. Can everyone see that? If you've got connectivity to that point there, we're now going to set it up so that way in the application, we're going to say, if we get a ping packet from host 1 destined to host 2, drop it. So this is important. If we go to our flow management, if you can't see this section on the right-hand side, it means that your screen resolution is too small. So the disadvantage of dynamic web applications is that it looks at your resolution to be able to display certain items. And if it's not there, you may have to run a script to do that. In my case, I can see this table, but if you can't see it, it'll be because your screen resolution. So you can see here, I've got these different flow entries already by default. I want to add a flow entry. I click on this pencil icon to open up my flow entry. It's going to ask which Open vSwitch or device that supports OpenFlow do I want to modify the table entry on. I've only got the one, so I'm going to select that device. Once I've selected that device, it now gives me on the left-hand or in the middle section here, general property details that I can set up, the fields that I can match on, and then the actions I want to do something for that match. So we'll start with setting up our general properties. So the general properties that we're going to use are some way of identifying this flow entry in our table. So you're going to use the cookie as an example, and I'll explain why when we do the demo, why I use a cookie, as well as the ID. And the priority is going to specify where it falls in that there's a double match. So the table that we've got is 0. That's our very first table. The identity I'm going to use is 0x102. And the priority, what did I say over here? I think I set it to 30. Yeah. I'll get rid of the X. Hex, I'll just set it to 102. Now that ID will display in our Cisco OpenFlow Manager, but when we look at it in our network simulation tool, we don't see that ID. And so I use the cookie to show that it's the same. So that's why I add the cookie here and I give that the 0x102. From an actions point of view, I want to look at the source MAC address and I want to look at the destination MAC address. So that, remember I said we want to stop host 1 from pinging host 2. So the MAC address is in simple form. So it's all zeros, 1 for host 1, all zeros and 2 for host 2. So I just go 00 colon and I keep going until, see this error message over here disappears. And that means I've now got the appropriate setting. So I've now specified some general properties. I've specified the 2 fields I want to match on. So the source and the destination. And then the action I want to do is to drop that. Did someone have a question? Looks like there's a few extra people here for those people who do want to follow the lab. I'm just putting the link back in again for the virtual lab if you want to log in and follow the lab. Now that I've built this out, I want to be able to, so I've already gone down to here. All of this is going to create a JSON file. So if I go show preview, this is it in JSON format. And this is the tool. This is the information that I would use if I want to use the command line interface to create this flow entry. So I've got the flow, the table ID, all of those fields that we've created here. It's dynamically populated the information. So if I close this down and go send request, This is now going to send that to my Open Daylight controller. The Open Daylight controller is going to keep that information, and when a packet comes in to the Open vSwitch that matches this, it will push down a flow modification to that device to drop the packet. Click on back, and I should now see, if I do a refresh, whether it's on the device or not. So in this case, it's on the Open vSwitch, so it's on the device. And if I do a ping now between host 1 and host 2, it should be dropped, but a ping between host 1 and host 3 should work. So going to my mini-net simulator, host 1, ping host 2, count of 2. I got 100% packet loss. But if I ping host 3, no problem at all. Arrow up, and we can now see the information here. We can see that we've got the cookie. I'm going to take this so you can see what I'm talking about. See how we don't have an ID field in this information here, but instead I've got a cookie of this 0x102. It's going to say that the source is this MAC address, the destination is this MAC address, the action is drop. Then we've got another drop here. I don't know what's happening with that one. But anyway. Import 1, import 2, it's going controller. So all of these are the controller communication. But the main thing is that we've got this flow entry here. It's matching our cookie 102, and that's how I can match it back to our ID here. If I arrow up after I clear my annotation, you can see that's hard coded in there. To remove it from our device, we click on the X, and that's going to get rid of that altogether. It's now removed. If I go back to my mini-net simulation, we can see that I no longer have that cookie in there. Was everyone able to build that out? The next section is we did it on the layer 2 information. So we're looking at the MAC address. What about the IP address? So rather than having to hard code it to a specific hardware level, we're looking at the generic IP address. So that means we can modify it. So it's a little bit different. You need to add a few extra things to that. So I didn't exit the MiniNet lab environment just to save time. So what we can do is that we can go in and add that flow again, specify the open vSwitch. We're going to specify the table as being 0. We can give it the same. What did I say? I'll set it the same. So 102, priority 30. I'm going to add the cookie. 102. And depending on what you do, we want to add an IP address. So we've got the IPv4 and IPv6. We want to add IPv4. Now, if I don't specify the ether type first, it's going to do a bit of a bug. Notice it's added the IPv6 details automatically for us. So that's a bit of a problem. So you need to turn that off. And when you go to turn it off, it automatically adds it in there. So I click that to delete it. I go to turn that off and it adds it in there. So just to fix that, the easiest thing is to basically delete those two like that. And we want to go and add the ether type. In this case here, we need to tell it that it's ether type 0x0800. It's down a bit. There it is. I'll scroll past it. Now, when I go to add the IPv4 details, it won't automatically try to add in the IPv6. Oh, it has because I've already did it when it was there. But if you do the ether type first, that will be fine. So we want to do the 10.0.0.1/32, going to 10.0.0.2/32. Making sure that you remove any of the IPv6 details there. And the action that we want to do is to drop that, and we can have a look at the show preview again. We can see that we've got our IPv4 source and destination, and we've got our type as being set to Ethernet 0x0800. Close that down, go send a request. Should get the success as being 1. Go back, do a refresh of my flow tables, and I should see I've got that ID 102 there. So that's how you can add a flow entry to an Open vSwitch using the Cisco OpenFlow Manager. And we can test that now on our device. I didn't do a count, so I'll just change that to a count of 1, so it times out quicker. We can ping our host 3 from host 1. We have a look at our flow entries. You can see that we've got the details there. So we've got our cookie right here saying that it's our source address. So we've got our source address rather than the MAC address. And the action is drop. Any questions about that? If we want to do all of this without using a web interface, we can communicate directly to our OpenFlow controller or our application using some sort of API, application programming interface, or REST-COM. And I've got some examples here where you can drill down and do that. So in this particular case here, I've got the curl command. Just copy that. Notepad. Just going to make this a little bit bigger. Now this is word wrapped, so you would normally do this on one line. So curl is a Linux-based utility that allows you to connect via the command line to a web address. So that's what we've got here is HTTP:/. What I need to do is some sort of authentication. So this is probably not the best way of doing it, but this is a very simple lab exercise. I'm saying user is admin, password is admin. What action I want to do in this case is a delete action, and I'm sending a header in the content format of a JSON file or JSON format. Where I want to communicate with is localhost 8181, which is my OpenFlow annotating, so I can't go back to it. That's my Open Daylight controller for OpenFlow. I'm using a REST-COM. I want to go to the configuration of my Open Daylight inventory. In particular, I want to look at my nodes, and I'm looking at my node OpenFlow:1, which is that OpenFlow vSwitch that we see when we go to topology, and we've just got that little square area. Then I'm specifying, look at the table for our flow entries, in particular, table 0. Look at my flow with the ID of 102. And what I'm saying is to delete that flow entry. So that's what that command is doing for me. So if we have a look up here, we've got our port 8181. That's what I wanted to show. We can see here we've got our OpenFlow vSwitch there. They're called OpenFlow:1, and that's what we're going to be communicating with. I'm just going to open up a new terminal window. And just to save time, I've actually made these last section, because some of you are probably not programmers. You can just type the text in, and that way it will put it in there for you. And if I run that now, it's gone ahead and deleted it. Now, no response is good. Notice I don't get any indication what's happened. But if I go to my application now, see how I've got my 102 there? I click on refresh, and I no longer have that on the device anymore. Then I'll just get you to test that you can ping each other. If we want to add the same flow entry in this case here, what we just created using the graphical user interface, what I tend to do if you're starting out is I use the graphical user interface to create the setup, and then you've got that JSON file that you can export and save to another location. And from that, you should be able to then build out this flow entry. Now, the issue might be that the latency sometimes causes some issues here, but what I'm doing just to save time is I'm saying, go create a file called flowentry.json, and inside that file, until you see the end of line, put this information there. So, and then all I'm doing is I'm running the command, but this time I'm telling it to use the flowentry.json. It's going to be a simple setup of that. I press enter. If you get an error, it would be because you've got high latency and it skipped something from when you created this text file. But now I should see on the device, if I do a refresh of the flow table, I've put back that 102. So this is one way to program your network using the command line interface. Any questions about that? Seems like no questions. This lab environment is available to you 24/7, so you can go over this lab as many times as you would like. There's also a video that goes with the lab. You're welcome to have a look at that if you're unsure. So I'm just going to go back to the slide deck and finish off the theory related to what we've just done in the practical. I just find it easier if you can do it a couple of times to try and visualize what's actually happening. So when we are creating our flow entries on our Open vSwitch, we're going to use some sort of matching fields. And we saw those fields in the Cisco OpenFlow Manager. As examples, we could match it on the port that it came in. It could match on the source MAC address or the destination MAC address and IP address, and so on. But those fields are extracted from the header information. And depending on which version of OpenFlow that you're running is what fields you can match on. Remember, OpenFlow version 1 only had 12 fields that it could match on. Whereas if we look at OpenFlow version 1.3, you've got all of these fields that you can now match on and build extra on that. Now, each one of those, each of the updated versions are adding extra capabilities and in some cases some extra fields. So from version 1.2 to version 1.3, we've added these extra fields here. From a counter point of view, being able to monitor and get statistics about what's happening on those flow entries, you can look at these sort of things like active entries in your table, how many flow entries you've received and packets you've received and the bytes, whether you're going to have queues set up, what's happening on your ports, and whether you're going to have some sort of meter that you can do policing on. Once we've got a match, we then need to have an instruction. That instruction is going to decide what to do with that. And that instruction is going to be like telling a modification to your Open vSwitch to do an action of some sort. Other instructions could include to apply, clear, or write different actions. Go to a particular table if you like. But essentially from version 1, OpenFlow protocol version 1, we had the forward, the set queue, the drop, and there was another one, group maybe. Whereas now with version 1.3, we've got these extra push pop tags and set fields, which allows us, actually it wasn't group, it was group and push pop tag are new from version 1, but it was set field for us. But from our version 1.3, we can now do some MPLS and VLAN support as well. So it makes it a little bit more functional for us to use in modern networks. So from our supported actions, we can, similar to what we saw with version 1 before the break, we've got these output options. So we can send it to a particular port. We've got the TTL modifications that we can do. So taking that, whether from an MPLS point of view as well. Then we've got our VLAN options and our MPLS. Remembering version 1 didn't support MPLS, and we've added that functionality. We've also got some other fields that we can modify from their point of view. From an action point of view, this is where we're going to decide, are we going to drop it? Are we going to write some sort of settings to that? But what you've got is this sort of things here. So we can do an order application based on the action that we're trying to achieve. So if we look at setting a setup, it's down at number 8. Whereas if we're looking at our time to live, or any of our VLAN MPLS functionalities, we've got these settings here. And so we're going to build out our instructions and actions to those instructions, but it's also got a application, the order of sequence is reliant on that. So if we apply an action, we're going to need to build something like this. So after a period of time, each packet needs to be processed and you apply an action to that packet. What happens if you've got a similar traffic for a group? So that's where you're going to create these buckets. So you can now start looking at your flow entries and looking at how you're going to do things based on a particular group or type. So each entry allows you to then build things up from there. So I find it a little bit easier. To show you this here. But essentially, we've got our group table that allows us to have an OR, which basically executes on everything in that bucket. We've got a select group or indirect or something to do with fast failover as examples. So when we look at this here, we've got our group table. Inside that group table, we have bucket 1, 2, and how many different actions that you need for a bucket, and it's going to apply for all of them. So to give you an example of this, if we look at the IPv4 protocol, if I have a broadcast address that gets sent to everybody in that broadcast domain, that could be a group. What about IPv6, where you've got all routers or all DHCP servers? That would be another type of group table that you could refer to there. And so what it's essentially doing is that it's going to take that one packet and replicate it to everybody inside that bucket. And whatever that action is what's going to be applied to that. On top of that, we can add different weightings to our different buckets. And that means that it will allow you to proportion the weight on that. It gets more and more complex as we go. And I suggest that because this is an introduction, that you go and read the specifications, because it's been modified hasn't been changed much lately, but depending on what programming language and the hardware that you're using and the software that you're going to be using, you need to figure out how to interact with that. When we look at our indirect group table, which has an ID of 3, it basically is going to send the same sort of thing to everybody in that. And the same for our fast failover. One important thing that is new to version 1.3 is this concept of a table miss flow entry. And so what that means is that when we have a packet that comes in, it goes to the controller looks at all the fields, and then if there is no match, what can I do with that? So it gives an extra default action if you want. And so it's similar to some sort of default action, what to do if the packets aren't matched. When we look at the meter table is going to measure the rate of the packets and looks at how to rate those packets as well. So it allows you to create these traffic control in a way of the flow entries. When we are building out our OpenFlow protocol, they have some what's called logical ports. Those logical ports are going to have default actions associated with those. And you have these OpenFlow ports. Obviously, physical port is your ingress and egress port that are physical. Your logical ports are abstract and they're reserved for that. And I gave an example of that with the broadcast address for IPv4. That's in a way a logical addressing. So when we're looking at these reserved ports, you're going to have this all sends it to everything controller. And we saw that in our dump flows on our I'll shut down. No, I haven't. If I go back to here, down here, see how I've got this controller as my interface to send it to. So we've got our controller, allows that communication there. We've got other things like a table, import, flood, and we saw the flood example before the break. I just find it a little bit easier to visualize this process. So what's going to happen is that you have your packet come in to your hardware device, the Open vSwitch. So the packet in, it goes to our table 0. And it looks at our table 0 for the flow entries. If there is a match in that, it will then do something with that. And it will keep going through that process until it finds a match in one or more tables. And that's essentially what's this first section here doing. Yep. So packet comes in. Is there a match? Yes. If there's a match, do the whatever the instruction is. Could be update action set, update or set a field, update metadata. Then it goes to the next table if we've got a pipeline happening. If it goes to the next table, it goes through the same process again and loops around. If it is gets to this point here and there's no more tables, it's then going to execute that information. If it goes through those processes and there is no match at all, it then gets to this table miss flow entry, which is that default action. And inside that, it may have an action to update or do something with it. Same process, it goes out the action set here. But if there's nothing in the default miss flow entry, then it's going to do the default action of drop that packet. So it comes back to what you're trying to achieve when you are setting up your network program. So every flow entry is going to also have a priority value set to that. The reason for that priority value is that that packet may match on more than one flow entry. So if it does do a match on more than one flow entry, then it's going to be the highest priority flow entry that's going to be used for matching with that packet. So that way you can influence and have backups based on different conditions. You also have the capability of linking your different tables together to do other actions on top of that. Now, I haven't built that into the lab at this point, and I'm just trying to keep it a very simple examples. But essentially, what's going to happen is that you're going to get your in packet. It's going to have a set of fields. Those fields are going to be looked up in a table. That table will have a flow entry, and if it matches, then it's going to do something with that. That's essentially what's happening. And it can also specify something like go to next table or flow table 1 or whatever. And you can build up this very complex processing on your packet. Obviously, the more flow matches that you have and the pipeline is very complex, it's going to cause some issues with your processing. So just be aware of that. So we can have this per table packet processing. So it goes, has an action set, looks up the flow table, adds that to the action set, and moves on to the next. So it's either going to modify, update, or update metadata. To give you an example, what we have here is your Open switch. It's got these Ethernet fields that come into our device, and it's going to have things like the MAC address. So think about a switch. It learns about your CAM table. That CAM table looks at my Ethernet address and then realizes what the IP address is. Output for that. From the firewall point of view, it looks at the IP address, and then you'll need to figure out what actions you want, what the port is. So you need to design your setup that way. The OpenFlow channel in the lab environment, we saw that communication happening using the snoop, the DPCTL snoop ampersand, and we could see the captures that are happening there. But if we go to our browser, and go to our cloud shark, we can see this is the communication that's happening with our device there using that secure channel. Now, when you are configuring your secure channel between your devices, the Open switch, through to your OpenFlow controller, you need to make sure that you have the physical connectivity on your network, but your Open switch actually uses a logical interface to communicate to that OpenFlow controller. And we saw that in the network simulator, that it didn't actually assign details to that. The OpenFlow controller is going to use that interface to be able to manage the switch and be able to obviously add or delete or modify our flow entries. There's one OpenFlow channel per OpenFlow controller, and so keep that in mind. And if you are looking at running it over an insecure network, you can use TLS, but you still need to have that TCP network connection between them. And if you don't, it's going to cause some issues. If you're only going to set up one controller in your network, then you're going to have issues from a reliability point of view. What happens if it can't be communicated to? If it goes down or you need to upgrade the software, it has a bit of an issue. So to improve your reliability, you would have multiple controllers. Now, if you have multiple controllers, then you need to be aware of the roles that are associated with those controllers. You have what's called equal, and it's older terminology, but secondary and primary, or slave and master. Slave is going to be a read-only access, whereas the master has full control over the switch. And the idea is that you can have your switch connected to multiple controllers in the equal state, or you can have your Open vSwitch connected to multiple controllers in the slave state. But if it's going to be written to, that Open vSwitch can only have one master. The connection setup between the devices and the Open Daylight or the OpenFlow controller will depend on what version of the protocol. So remember, I pointed this out that the port 6653 was anything below the 6653 as of version 1.3. Anything below that was using 6633. So just be aware of that. If my Open vSwitch device cannot communicate with my Open Daylight controller, what happens with the packets? Well, it depends on whether it can be, whether it's a hybrid or an OpenFlow only switch. So what you have is, if it's a hybrid, it can do what's called a fail secure or fail standalone. Fail secure means that it's going to drop all of those. So it's not going to, all packets that are destined for the controller basically going to get dropped. However, if there's already some flow entries in the table, then it's going to use those as normal until they expire. Whereas if I do a fail standalone, that means that it's going to act just like a normal switch. It only applies to our hybrid mode. In version 1.1, it was referred to as emergency mode for our fail secure mode. The type of messages that we get is going to depend on what's happening and what you're trying to achieve. So you have communication between your controller and the switch. You've got communication that is initiated from the switch to the controller, and then you've got any device can communicate. When we look at our controller to switch messages, it's going to be using one of these options here. So I think I've got a table a bit further on. Yeah, there we go. So this is the easier way. One thing I should point out, I've mentioned about the different protocol versions there. Fine. So our OpenFlow messages, controller the switch, it's going to have this ID type. In our Wireshark example, I mentioned the type 14, and I got you to look up that, and it was our flow mod. We also looked up type 13, which is our packet out, and our type 10, which is our packet in. So you can see from this that our controller to switch was doing this type of communication. Asynchronous is our switch to the controller. So that was the packet in. And then symmetric is that being able to communicate either way. Notice we had our people live messages in here, the hello and the echo request, echo reply. So depending on what you're trying to communicate with is which version of the message type will be symmetric, asynchronous, or controller to switch. So when it first starts its connection from the device to the OpenFlow controller, it's going to have to negotiate what version it supports. Remembering that it is not backward compatible, and it will only go to a version that they both can communicate on. It can also request that it has a TLS session established using the feature request. And all of these fields that I'm going to go through are actually in this packet caption here. So if I click on the link here for our feature request, we can see that we've got our the feature request number 5. Let's get a response if I can get in there. And I'm going to zoom in on that so that we can see a little bit better. Our capabilities, flow statistics. It's true, table statistics, port statistics, group statistics, IP fragments, queue, switch will block looping ports, what actions it can support. And we can see all of this information building up here. Now, this is only version 1. Remembering up here, we can see what version we're referring to on the wire, but that is a breakdown, nice little summary. I find it easier to visualize rather than looking at these in our PowerPoint deck. Now, I'm going to let you have a look at this in your own time. I'm not going to spend as much detail going over each individual one of these fields. But essentially, what it's going to do is do one of these 5 possible operations when it receives that modification message. It's going to add, modify, delete, or it's going to use a strict version of those. So that means it's going to be an exact match of all the fields, including the wildcards and priorities. And if we look at that flow mod, we do a packet capture. You can go have a look at that. We looked at that already in the practical component. I'm just going to drop out of the fields. Each one of those is just going into a little bit more detail about each of those fields. And I'm going to jump down to this. So let's break it down. What happens when your controller and switch start up? Well, they're going to have that TCP handshake, but after they've done that and they've got a physical connection, it's going to start the OpenFlow session. So it needs to have that exchange of hellos. And as part of that exchange of hellos, it has the version negotiation. Once they're happy on the version, it's going to have the controller ask the switch, what do you support? And the switch is going to reply with information. It's also going to receive a packet in, and reaction to an unknown packet, it's going to then specify what to do. And then it's going to say, do this flow modification for later on, and it gets added to our flow entry. And we saw that example in our lab environment. And we also did a Wireshark capture of that. And I pointed you to the CloudShark version as well. So we can see all of that based on our lab. What it does do though, and what we haven't spoken about, is how does the OpenFlow controller learn about the network? It uses a mechanism called topology discovery using what's called OpenFlow discovery protocol. And it's an older mechanism of doing it, but essentially what it does is that when the switch starts up and it starts communicating with the OpenFlow controller, it's going to use the link layer discovery protocol and tell the device to send out certain packets. And it's going to say, communicate with our controller for that. And I've actually got a nice little diagram that demonstrates this. So what we have, step 1, our switches create a secure channel to our controller. Once we've got our secure channel with the controller is going to learn about the ports and the features that the OpenFlow switches support. Then the controller is going to say, okay, I want you to send out a link layer discovery protocol to everybody. And if you receive this link layer discovery protocol, send it to me. So all of those are going to now receive a link layer discovery protocol packet. So the controller, in this example, let's zoom in on switch 1. So in its flow entry, it's got that previous flow entry of if you receive a link layer discovery protocol packet, send it to the controller. The controller now sends a packet out message to the switch, and it's specifying the port P1, and it's going to send it out this port here. So remember, it's going to send it that way. It also sends another one to send it out this port. So let's go to the other switches. So we now go to switch 2. Switch 2 is going to receive a link layer discovery protocol on my P1 interface. Switch 3 is going to receive it on its P1 interface. Since they both receive a link layer discovery protocol message, what was the flow entry table when it matches? Send to controller. So it now sends that information to the controller, and the controller gets this packet in, which is on port 1, I received this type of packet. What should I do with that? And I received it from this chassis ID of ABS1 from port 2. And the same happens with our switch 3. It sends that up. So based on that, the controller can build out the network topology. So it now knows that on port 1 of OFS1, that's switch 1, it's directly connected to switch 3 for our port 1 and switch 2 for our port 2. Based on that assumption, it could go to our switch 2 here and specify, I know that's now connected to OFS1. And my switch 3 can do the same for its OFS1. And then it will repeat that. It will send a link layer discovery protocol to switch 2. Switch 2 sends that out to switch 3 and switch 1. And that information gets sent up to the controller, and it builds out our configuration. Any questions about that? So one thing to be aware of is that when OpenFlow was designed, it has some exclusions. If we look at the OpenFlow control information that happens between multiple controllers, it doesn't handle that. So you still need to configure that. OpenFlow is not used by the northbound interface. So it's using a different configuration, so the REST API or some other mechanism. It's only used between the controller and the devices, not the application above the controller. You're going to have to think about when you are doing the setup of your network, how do you bootstrap your network? And how do you have it traverse multiple OpenFlow switches if you're going to set that up? The slide deck goes for a little bit longer. I'm not going to cover that, but that's for our OpenFlow version 1.5, which is the latest version of our OpenFlow protocol. I've left that information in there for your own reading, but essentially we've covered most of the content I wanted to talk about today. Are there any questions about what we've covered? if there's no questions, thank you for your time. You're welcome to continue with the lab, or if you were not able to start the lab, and for those people that arrived a bit late, you can access the resources. So I'll just put a link in Zoom that gives you access to the resources. On the wiki page, so you'll be able to access these details here. And if you want to have some practice with the OpenFlow protocol, there's a virtual lab here and the video tutorial if you want to access it there. So I hope it was informative and you're able to learn some settings. The main thing is to think about how you could use this environment use it in your environment. Some people tend to use vendor solutions now rather than build it themselves. But if you've got a large workforce where you've got programmers, then you can utilize quite a very you can utilize your skill sets and customize your network to suit your business needs better using your own programming in-house resources, building your own custom environment. Otherwise, if you look at vendor solutions, they're going to build it based on their use cases that they've come across for their customers. So it may not necessarily be suited to you. If you are interested in a working example, the University of New South Wales actually used this concept to dynamically inspect traffic from a DNS point of view, and were able to pick up malicious traffic, which they weren't able to do with most of their vendor security products. So there's a nice little white paper about that in 2019. He went around talking about what he did for the University of Sydney. So I think I've got a link on here. Oh, no, I don't. But yeah, there's a whole heap of extra resources that you can access. So hopefully it was informative and you enjoyed it. There's no other questions or no questions. We may finish early. Thank you, everyone.